Yeah. Okay. Yeah. Sorry, but yeah. Mm, okay. Yeah. So I will maybe start from next time. Uh, okay. Anyway. Okay. Dx dv. Okay. Theta f is bound, right? The smooth solution satisfy. Um, so lambda f. So some lambda f, which is just a constant, right? We will need this, but you don't need to know why we need this. But in the last step, when we need to complete the estimate for relative entropy between f tilde and f, so we need that. Okay. So the relative entropy between the relative entropy between f tilde and f can be written in the following way. Can be written in the following way. So this is RD, so dx dv. You can check easily, right? Since f and f tilde are both probability density, the relative entropy is always positive. It's not a metric, but it's a good quantity people use to measure the distance between f and f tilde. It's also called divergence. It's called KL divergence. It's also called KL divergence. Okay. Um, yeah. So we just actually so the argument is very easy. We just evolve the relative entropy HT, and we want to complete the estimate of HT. So but here so F, right, F is a weak solution, right? We cannot really compute, right, the derivative of F, but we must using a test function but the commutation is exactly the same as they are both strong solution. Okay, so F is a weak solution. So but F satisfy F tilde satisfies the entropy bound. So F is kind of entropy solution, so which dissipates entropy. So entropy is just F log F. So satisfy the following property. Okay. Um, I want to like save some time. I just do a little bit quick. Um, so if we want to estimate, so we can assume, right? So f is smooth, right? Using convolution, for instance, and in the end pass through limit, and we can assume from very beginning. So this f, the smooth solution is like C1, for instance, and bounded and does not vanish anywhere, right? So later we can pass through limit, but let's just do the formal computation, which actually is not really formal, it's exact. Okay. So first, so we can estimate this. We can, right? So just write as the difference. Okay. So since F tilde is entropy type like weak solution, right? It dissipates entropy. It satisfies the entropy inequality. So we can rewrite. So F tilde 0 are initial data. Okay. So so now we use log f, right? So we use log f as the test function, right? Since f is as nice as possible, we can assume. So we use log f as test function, and this term, so this term can be, we can use the equation of f, right, to estimate to estimate these terms, right? Okay. So F tilde is a weak solution, and we can using log F as a test function. So this term can be write using integral, right, from 0 to t, right? So then, so this part actually just the joint operator applied to log F. You can check this. The joint operator of the Vlasov equation applied to log F. So because here we, yeah, yeah, log F plus sigma gradient V log F. Okay, so we can wrap up. So we can substitute this equation to HT, to HT. So we can get the following estimate. So we can get, I just skip many middle steps, but we can get the following. Right? For instance, right, you can check this. Let's introduce R, right? dx, dv, ds, right? S is time variable, and minus sigma from integral f tilde. So that these terms, this, okay. So so actually, right, I claim you can check this, right? This is you can check this, which is just f tilde f square, and this is positive, right? So we can just using integration by part, and we basically can store this term away. So this term is always positive, right? It's minus a positive term. So we have this. So where R equals to, so R is the term which measure the distance, measure the difference xv, right? Okay, so in the following, we just need to control the following. We just need to control, we control ht, right, of this equation, right, using Grunwald. But of course using Grunwald in the last step, but we need to think a way to control ht, like given by this inequality. Okay. Maybe let us stop here. Maybe starting from here next time. Okay. Yeah, I will stop here. Yeah, I forgot to record this lecture. Yeah, if you have questions, you can ask. But I can only post the notes this time. Yes, it's basically the same. So there's student Zimo Hao asked, does the distribution estimate applies to SDE? Yes, it applies to, but usually we call that coupling method. This is just what I showed here. What I showed here, but the exactly estimate is not true, right? So because now we are not right. It's not the initial data, right? It's not deterministic, right? Okay. Yeah. So no more question. 没有别的问题吗？OK OK，如果没有别的问题，我就先我们周三早上。